Name is K.W. Greager. I go by Wally. Greager is spelled Greager, slightly different than the earlier Greager.
Okay, now you want to tell us about when you started working at Hanford, and then go into talking about the two issues we talked about.
Okay. I started working at Hanford after college in late 1951 on a rotational training program. I spent 4 years in the 300 area, fuel preparation, slug preparation. I wound up out in the 100 areas, the reactor areas, in 1956-57 time period. And I suppose the B Reactor Association really comes with radiation monitoring and with supplemental crews, which means charge-discharge. Each of the reactors be included, but each of the total of 8 reactors was operated 24/7, 365 days a year. There was a skeleton crew there. During an outage, during charge-discharge, there was a supplemental crew, hence the name, supplemental crew, that was brought in and did the grunt work, if you will, on charging, replacing the irradiated fuel that was in the reactor. Now, it's already been mentioned that there were 2004 tubes, and we did not replace the fuel in all 2004 tubes. But there would be perhaps anywhere from 150 to 250 tubes at a time that we would go in and discharge the fuel by charging in new fuel. You have to visualize a roughly 2-inch diameter aluminum tube, and the fuel elements, the slugs, the irradiated fuel, was held in the center of the core of the reactor by the fact that there were dummies, perfs, pieces of aluminum that did not have any value as fuel to be irradiated, but that was sitting against the cap on the rear face of the reactor. A train of those dummies would hold the fuel in a particular sequence in the middle of the core. Now, in order to change that, to replace that, you had to do some valving, otherwise you'd get pretty wet. But you'd do some valving, you'd remove the cap off the rear face of the tube or tubes, remove the cap off the front face of the tube, and begin charging in new dummies, new fuel. And so by displacement, you would force the old material out, and it would fall into the pickup chutes off below the rear face. The water there was probably somewhere approaching 20 feet in depth, somewhere between 18 and 20 feet in depth. After being involved with that, I was into an industrial engineering organization where we tried to simplify some of the work activities of people on supplemental crews and in other areas as well. One of the things that we came up with was what was called the pre-insertion of downstream dummies. Instead of charging these 8-inch long dummies in with the charging machine, you would slip them over a piece of aluminum tubing that was roughly the configuration of a piece of conduit, maybe 5/8, 3/4 of an inch in diameter, and you'd put a train of them on there, take the cap off the front face. Instead of charging in all the dummies, you would take the cap off the front and insert that string of dummies and pull the aluminum tubing, the small piece of tubing, out. Then you could hook the charging machine up and charge in the fuel elements. And again, you have to think of this as a train that where you're displacing. That's the discharge aspect of charge-discharge. You're displacing the material that's in there already. When you wind up after charging the tube full and having displaced everything, the first dummy, the first usually red in color, anodized aluminum, is the thing that's sticking as closest to where the rear cap was. Then you retrieve with a perf retriever. There's one on display out there in the work area at B Reactor. You'd retrieve the upstream dummies, and now you wind up with downstream dummies holding the fuel elements to become irradiated, holding them in the proper position in the reactor with the front to rear relationship. The water flowing from the front to the rear. During operation, that water was under considerable pressure, and if it weren't for those dummies downstream, it would just move those heavy uranium fuel elements downstream. So that's what charge-discharge amounted to. In other areas with the industrial engineering group, we came up with a ramp for unloading the semi-trucks that came from the 300 area out to the 100 areas, carrying fuel elements to be irradiated. The Magnaliner ramp was light enough that a couple of men could move it into position and put the brakes on, and then you could run a forklift up into the 18-wheeler that was hauling the fuel elements and back down. That was one of the things we got involved with. There were others, many others. One of the interesting things, just as an aside, we were headquartered at F area, which was at the opposite end, the most downstream reactor of the B was the first, most upstream. F was the most downstream. But at F plant, there were some other activities. What is now Battelle had the famous smoking beagles. They had a bunch of beagle dogs in there that they had smoking cigarettes so they could check and see what, I say a bunch, they must have had about 20 of them, to find out what impact the cigarettes had on the tissue on the inside of the dogs. They also had pigs of various types. The pigs, it turns out that the epidermis of a pig is very similar to that of a human being, so they could check the impact of radiation on the epidermis of pigs. They also had monkeys. They had alligators at one time. Small alligators, about, I don't know, 2.5 feet long. And they had to rig, they had fish because they were checking the impact of radiation upon all kinds of flora and fauna. 2 of the alligators got away from them one time and got out in the Columbia River. They didn't live in the cold water of the Columbia River, but they'd been under heat lamps in little ponds around F area. One of them was retrieved by an astute fisherman, civilian fisherman, somewhere in the Columbia, and it wound up being put on display very briefly in a window of a sporting goods store in downtown Richland. I say briefly because about 2 days later, some gentlemen dressed in suits and vests and not looking very happy, came to the sporting goods owner and said, "We will now take our alligator and take him home," even though it was dead. But there have been, there were a number of things that the industrial engineering group worked on. We also did a number of, I had occasion to do some films with 16 millimeter camera. I had a Bell & Howell 70D with the back cut, so it would take a 400-foot magazine, and used to do different films of maintenance and operating activities, and show them to the folks as part of training sessions to give them an idea of why we wanted them to do things a certain way. Even things as simple as using a step-off pad to disrobe when you're coming out of a contaminated radiation zone. It was amazing to show them their films of what they looked like when they were doing that. Not in their underwear, not that part of it, but the fact that they were, 9 out of 10 of them were doing it all wrong and tracking contamination out into what was supposed to be an uncontaminated zone. But we're still going, are we?
Yeah, Mr. Greager?
Yo.
I can hear you rubbing your hand.
First of all, you have to envision an aluminum tube about 2 inches in diameter, not quite that much, but almost, and 40 feet perhaps long, with water flowing from one end to the other. During the operating phase, that water is under considerable pressure, flowing from front to rear, from one end to the other. So in order to hold the fuel elements in the specific location you need them to be for irradiation, the quote downstream, end quote, dummies were inserted first in the tube, and then the fuel elements, and then all of that was pushed front to rear from one end to the other by another string of dummies, and then those dummies were withdrawn, were taken out. Once the front and rear caps were replaced and the water pressure increased, the downstream, the first dummies that were put in, would hold the fuel in the proper configuration as far as irradiation is concerned. You have to, I guess, recognize, first of all, that when you talk about the reactor, you're talking about a graphite cube which is surrounded by shielding. And the shielding, in effect, is why you put those downstream dummies in, so that the fuel is in the core, in the graphite, where it's being irradiated.
Great.
Still sandpaper?
That's fine, thank you.
Wally, you can talk about pressures and temperatures and flows of the reactor. It's not a problem. So you don't have to walk around it.
I'm not walking around it. I'm not an engineer.
Okay, that's okay. I just thought you might, I'm just trying to tell you that it's
Fine.
not a problem. Temperatures and pressures and flows are not a problem for reactors.
But what did you think of that system? I mean, what was it, did it seem Rube Goldberg to you? Did it seem ingenious? How would you characterize it? Because this was the first time anybody had done anything like this.
When you recognize that you can't walk up and pick up one of these irradiated fuel elements, well, you could once, but you wouldn't do it again. And you had 32 of them to get out of the reactor, and you had to be concerned with a rather intense amounts of radiation. Lethal would be putting it mildly. So you had to be concerned with shielding. You had to do these things remotely. So the idea of how could you, I guess you could have put some sort of a plunger in the tube and pushed that out. Then what would you do with the plunger? Because you'd be putting the plunger up against irradiated material. So yes, I think that it was, as many things in B Reactor and the other older reactors, as many things were, they were pretty simple and pretty straightforward. Genius, yeah, there was a lot of that, because you have to keep in mind that the work that was going on at B Reactor and the other older reactors was people didn't have a long period of experience with this. They had to make do as they came along. There were a number of, interestingly enough, there were a number of Rube Goldberg type people who in effect had carte blanche there. There was, I later got involved in campus recruiting, college recruiting, and I used to enjoy bringing BS, MS, PhD engineers for plant visits. And one of my favorite people to have them visit was a guy named Charlie Franz, who was one of those Rube Goldberg guys. And I can well remember that after spending 30 minutes visiting with him and visiting some of his work areas where he was working, he kept 2 draftsmen busy all the time drawing up his thoughts. But they'd come out after a 30-minute visit with him speechless and eyes as big as saucers, because they had finished their academic training, but this guy, who'd never been to college, by the way, had come up with some things that were strictly Rube Goldberg.